All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Language Fundamentals class, I've been doing a series of video presentations based on the book for the class, that book being Muroc C# 2015. And so far I've done the 3 chapters in Section 1, the 8 chapters in Section 2, the 5 chapters in Section 3, and I just started with the first part of Chapter 17 in Section 4. So I'm going to pick it up from there. And it talks here about the Server Explorer design window for the invoices table. What I'm going to do, not right now, but later, is I'm going to build a very simple database for you so you can see this stuff, as they say, in action. But what you have here are the names of all of your fields that are in the table. This means that it is a primary key. You can see the little key thing. This is the type of data. Integers are whole numbers. Date time is just that. And these are decimal or monetary fields. None of these are checked, so that means that every one of these fields have to be filled in. If any were checked, it would mean that they could be left empty or null. We have no defaults. We have a primary key for our invoice ID, and we will have a foreign key, which I'm not going to get into right now. So these are some of the common types of data. A bit, which would be a 0 or 1 on off. A char, which means typically if you say state, if I've got a field called state, and I'm going to use the state abbreviation, I make it a char 2. MO for Missouri, IL for Illinois, FL for Florida, etc. Varchar is, so this is fixed length. Varchar is a variable length. You can also use nchar and nvarchar. They basically mean the same thing. Date time fields, decimal fields, numeric fields, fields that are not decimal but can have decimal places in them, whole number fields, monetary fields. So we're going to look at this MMA Books database. Maybe we'll even create the entire database ourselves. If you notice, it has 1, 2, 3, 4, 5, 6 tables. All right. The customers table is connected to the invoices table. The customers table is connected to the states table. The invoices table is connected to the invoices line table. The invoices line table is connected to the products table. And you've got this order options, which is kind of in an island into and of itself. You'll notice there's a key, and then it looks almost like a number 8. The key is the one side. The little 8 is an infinity symbol, which means many. So there is a one-to-many relationship. Every one state can have 0, 1, or more customers from that state, for example. All right. When you work with SQL, the structured query language, you typically do one of several kinds of statements. So let's suppose, I'm going to keep that up here, but I'm going to go to another page. Oops, that on that other page, that what I want is I want to select every field there is from a table that's called employees. I type select star from employees. Now, SQL is totally case independent, but I used uppercase for every keyword and lowercase for the name of my table. Let's assume that that employees table has in it, we'll call it emp first name. It has emp last name, emp address, emp city, emp state, emp zip, and emp phone. In addition, every employee has got an emp ID. All right? So when I say select star from employees, it gives me all of that information for each employee. It's as though I typed in select emp ID, emp first name, and I can put this over multiple lines, emp last name, emp address, emp city, emp state, emp zip, emp phone from employees. So those two, if this is what's in my employees table, this statement and this statement are the same. Why would you use that one? You wouldn't. But if all I wanted was the first name, last name, let's say, maybe ID, first name, and last name, then I have to do it like this and list those fields name out individually. So when you do a select is kind of known as a get. It's an accessor. If I say, hi, what's your name? And you tell me your name, it's a select. I'm getting your name. So I can select one or more fields from one or more tables. I can put where on there. So maybe what I want to do is I want all the employees where, let's put another field in here. We're going to call it emp department. So we'd have to add that here too if we were doing all the fields. But I'm going to say here where emp department equals accounting. Now it's only going to give me those people who work in the accounting department. Whereas if I leave this off, it'll give me all employees, regardless of what department they work in. All right. I can also do order bys. So this will give me the name of each employee, the city they're located in, but only if that state that they're located in is in Washington. And then it orders them by name. This is a very poor example because it's a very poorly set up. You wouldn't have one field in there to handle both first and last name. You see some of the problems with it. Okay? Sometimes they have initials, etc. Who knows? So to query a single table, when you write something like I showed you, you get what's called a result set. You can also have calculated columns if you want. What does that mean? Well, if in the example that I showed you, let's assume I also have in here, all right, after the department, I have emp hours, and I have in here emp pay rate. All right, so I could do these, and then I could also add, for example, emp hours, emp pay rate, and then I could add what's called a calculated column where I would say emp hours times emp pay rate, and I can give it a name even as gross. All right, and it'll multiply one by the other, give me the result, and call the column gross. All right. And joining is a beast into and of itself, so I'm going to stop right here, and I'll pick it up then with the next lecture.